I'm Pam Hoffman, Everyday Spacer.
I'm Jeff Miller, See Me Computer and IT Solutions.
At Everyday Spacer, we show regular folks how to personally and directly participate in space exploration, science, and astronomy. We're here on Friday nights at 9 p.m. Pacific Time, 12 midnight Eastern Time, and 12 noon on Saturday in Hong Kong. We're broadcasting live from Thousand Oaks, California. Thank you so much for being here. I see comment ready. Hey, Dawn, welcome.
Hi, Dawn.
Glad you could be here. All right. You want to do this? Cybersecurity news? Yep. You just talk about them? Because
go ahead and show it.
Oh.
Right
yes. There it is.
Okay. Another FBI flash cyber criminal group, and this won't necessarily mean anything to you, is compromising Salesforce instances. And this doesn't apply to a lot of people, but some of you might work for a company that uses Salesforce. So, so just letting you guys know that this is here. They also give, the technical details. Again, this doesn't really apply to many of you, but it does give some interesting, like this indicators of compromise. Basically, these IP addresses are ones that show up in the logs if they've been compromised. So this is something that your IT, and these are URL links, again, more indicators. So this is getting a little bit technical in this end, but if you're curious, this gives a good way of learning about the terminology and stuff. So I will put this link out for you.
Great.
But like I said, it probably doesn't apply to most of you, but that's fine.
Something weird with this platform tonight.
Yeah.
I do not understand it. So we'll just be back and forth.
Yep. And
we scheduled another Zoom call for you on October 1st. To get on the list by sending an email to jeff@cmeit.com or me. That's right on your screen now, pam@everydayspacer.com. We still didn't make one for you, sorry.
Oh,
been a busy couple of days.
Yep.
All right, so tonight we have a crunchy topic, the elliptical galaxy. We'll be back in 8.3 seconds. There's a link to that book in the description. If you want a signed copy of the hard copy of the book, go ahead and write to me as well at pam@everydayspacer.com for details. There are three major types of galaxies: elliptical, spiral, and irregular galaxies. We covered spiral galaxies in a previous episode. That was actually May the 9th of 2025, which seems like a really long time ago now. Tonight we're going to talk about elliptical galaxies and their remnants of collisions between the spiral and barred spiral galaxies that most people think of when they think of galaxies. So Jeff, tell us about these galactic remnants and how they relate to our Milky Way. You ready for that?
Yeah. Okay, this is, these are the four main categories of galaxies. And I just wanted to show this just because it lays them all out. Elliptical, irregular, spiral, and barred spiral, although these are kind of different types of the same. Arguably, so are these. And a lot of people are used to seeing this image here. And this was the one that Hubble created when he was doing his observations.
Okay.
And the ellipticals, the E's, going from round to slightly off round to more and more until it's a full ellipses, and then progressing to the types of spiral galaxies. Lenticular is basically this whole category of galaxies.
Hey, Cliff. Karen had surgery, but good day.
Hi, Cliff.
Cliff, thanks. I'm glad you're here.
Yeah.
I hope it went okay.
And Hubble believed that this was a progression that galaxies spun until they formed a spiral, until they flattened out enough to be a spiral. That is actually not the case. In fact, a lot of these different shapes of elliptical galaxies are basically all the same shape seen from different angles.
Ah, that makes sense. So if you're straight on or if you're
Right, yeah. So,
partial,
yeah.
do you think they're generally the same shape? Or
I think so, but I don't think that there's enough, solid about it to say that there's. Oh, hey, Jamie.
Jeannie made it. We just saw her today. Happy Friday, Everyday Spacers from Westlake Village. Yeah.
Yeah,
We'll see her again tomorrow.
yeah.
Yay.
Yeah, I thought you might be a bit busy tonight.
Yeah.
So, yeah, and this is just another image there that shows this as a progression when, I've got a number of different things here that, sites here that talk otherwise, in that most of these stars in these in the ellipticals, are older stars. There's very little star formation there.
Okay.
And it's not, and there's very little dust in there too. So there's not a lot of material to create new stars. So there's no clear path from elliptical to spiral.
Ah, okay. Because of those conditions.
Yeah, but also ellipticals typically are heavier than spirals.
Okay.
So now it's believed that ellipticals are the result of spirals that got whacked by other spirals or by other galaxies, and that everything just came around, and when things settled out, they weren't in a spiral anymore. They were just there, but the interstellar dust and stuff either got blown out by the interaction between the two, or when the two galaxies hit each other, I mean, it's not like they pancake against each other, because there's so much space in between them that they just kind of go through each other.
Space is big.
But
there's gravity involved.
Yeah, but a lot of new star formation there. A lot of stuff gets kicked out. A lot of stuff gets sucked up by the two black holes of the two galaxies.
Ah.
And so by the time things settle out and the rash of star formation is gone from the gas clouds, that's hard, the gas clouds hitting each other as they're passing through each other. Okay. Once that's all done and all those stars are there, there's not much left but stars and the the black holes, the supermassive black holes.
And is that where they're seeing them kind of come together? And
yeah.
Okay.
But I don't think,
which makes them
they're not
more
really
massive, right?
They're not really ellipticals at that point. It takes, that happens, I think, before everything sorts itself out to be elliptical galaxies. Okay. I'm not positive on that. And
there's some things happen with was it LIDAR? We were just looking at the other day.
Yeah.
Where they're seeing these more and more, and I guess they've had upgrades which made them more sensitive. Hey, Naomi, welcome.
Yeah, hi, Naomi.
So glad you're here.
But so the different shapes are just different angles often.
Okay.
Now, ellipticals,
like seeing Saturn's rings from different.
Yeah, exactly
positions.
That.
Got it. Okay.
But also, the sizes of ellipticals can be very small to very, very large.
I remember reading something about trillions of stars involved. Which,
yes.
Like our galaxy probably only has 100 to 400 billion stars.
Right. Yeah.
That's far cry from trillions.
Right. Yeah. And as more of these hit each other, also the fact that ellipticals only really show up in galactic clusters. There's very few of them, in the areas where galaxies aren't common. So they only show up where collisions are more likely. So there's a whole lot of evidence to indicate that they're the results of collisions.
Because I guess even though the universe is in general expanding, some of like in our local cluster, they're actually getting closer together.
Right. Yeah.
Interesting.
Yeah. So eventually the local cluster will all compress in. But then
long time from now.
But here's the thing, with the expansion is actually accelerating, which means that eventually the expansion will be faster than the speed of light. In fact, the farthest area, well, yeah, because
supposedly nothing can go this faster than the speed of light.
Except that space is being created, and it's being created.
And the rules are changing.
The amount of distance between two things means that more space can be created in there. So the farther away something is, the more space is being created, and it's getting farther and farther. And so the 2 points are getting farther and farther away faster. It's not, and they're not actually moving. That's the whole thing, is they're not moving. There's just more space between them. So that,
where does that come from?
Yeah, that's a question.
So much to learn still.
Yeah, that's
Isn't it wonderful?
Yeah. So there's, so the expansion is not actually movement. It's just the space is being created between them. Whereas the galaxies, the clusters, contracting.
Maybe that's where it's coming from.
Is actually movement. Because gravity is, basically everything's rolling downhill toward each other.
Okay.
That's kind of the way
gravity well.
Yeah.
Kind of, yeah.
So.
Okay.
So there's a lot of evidence now that these are created from remnants.
And if that doesn't bend your head.
Yeah.
Go back to your screen.
Yeah. Okay. And just now it's pretty pictures.
Beautiful.
Pretty pictures.
Amazing.
The history of information. Basically, they're thinking that after the Milky Way and the Andromeda actually whack each other in a few billion years, they'll eventually, they'll get a weird shape, and then they'll eventually settle out into an elliptical.
And there's some pretty good examples out there of galaxies that have gone through each other or coalesced somehow.
Right.
Beautiful, beautiful images. I mean.
Yeah. And here's the thing. And they talk about the gas giants consuming, or the supermassive black holes consuming the gas and dust. And it kind of makes sense because without the spiral, the centrifugal force of the spiral, keeping the dust out there, since things are going to be moving in all different directions. And so just by the friction, and I don't mean friction necessarily of hitting each other, but just of the drag of the mass against each other, will slow their movement down until everything's kind of, settled into like its own movement, but which means that the force keeping stuff away from the black hole decreases. There's no centrifugal, pressure keeping things out, so it spirals in a little bit easier.
Okay.
So that's what they're thinking.
It seems like that'd start to be looking like your drain and your sink,
right,
because the black hole will bring that in and
right.
Won't go straight in.
And they don't mention it here, but they're probably going to blame dark matter for keeping that stuff out of the black hole. But I don't know. They don't mention that, so I'm just throwing that out there as my uninformed opinion. Not that I think that that's what's happening, but I think that that's what they'll eventually decide is happening.
Okay, all right.
But
well, that's the beauty of science. It keeps we keep learning new things. We keep doing experiments. We keep finding, making these discoveries. And at some point, it'll be like, oh, wait a minute, no, the Earth does not. The sun does not revolve around the Earth. The Earth revolves around the sun. And we'll know the truth.
And could be that there's something else, some other explanation, but this explanation fits best with what they've been able to discover. And since there's
that's cool.
Since there are no gas clouds out there, when a star actually does nova, it will produce a gas cloud, but there won't be anything for that gas cloud to hit and thus spark more. So it'll be an expanding bubble. And so every once in a while, a couple of these bubbles might get close enough to each other to hit each other and form a star.
Okay.
but it's not. It becomes less and less likely in an elliptical, because eventually those bubbles get thin enough if you get far enough away that it doesn't really do much. So that's why they're saying that there's no star formation. There are also a lot of redder stars.
They're older.
Yeah, they're much older stars.
Yeah. Okay. Oh, wait.
Oh, no, I'm not showing pretty pictures yet. I think we're pretty much done with that article.
Okay. Let me know when you want to.
Yeah, let me look at. Okay, and some other sources. That was space.com.
Yeah. Now?
Yeah,
okay.
And this is sentinelmission.org, astronomical objects. And I'm showing this. It says basically the same thing. They talk about the classifications of elliptical galaxies.
Is that like what we were seeing with the
E0,
E1,
yeah.
E2? Okay.
But again, are these actually different shapes or different views of the same shape? Yeah.
Yeah, it's easy to see that they could be different views of the exact same.
So
kind of.
This doesn't have much more than the wiki. I haven't shown the wiki yet, but it actually.
Okay.
But this one actually. This is
Nada.
It's
Andromeda.
Telescope Nerd.
Oh, cool. That's a new one to me.
Yeah, that's Andromeda. But
I forget there's two galaxies there. I forget what the other one's called.
Right. Yeah. But this is what is an elliptical galaxy? What is the shape? Well, gee, what's the shape of an elliptical galaxy?
Hello, Hank Cherry. Welcome.
Hello.
Thanks for being here. Could an
elliptical galaxy be in the shape of an ellipse? But hey,
I don't know.
Some people have to say it. Now, an ellipse, an E0 is because an ellipse with zero difference is a circle. So, but the reason why I showed this one, and I might share this link too, is that it has examples of elliptical galaxies.
Oh, cool.
And what are the facts? Again, here's where I missed this the last time I read it. Dark matter comprises 90% of the mass of elliptical galaxies.
Okay, which seems about typical for
right
most of the other galaxies as well.
Yeah. So, what is the elliptical galaxy that is closest to the Milky Way? Sagittarius dwarf elliptical galaxy.
Oh.
Like I said, there are different sizes. Some of them are really big. Most of them are bigger than our galaxy. Some of them are fairly small.
A lot of stuff going on in that area. That's like where some of the first planets, exoplanets were found.
Yeah. Which my guess would be that the really small ones are, say a black hole with its galaxy went through another one and was smaller in the first place and lost most of its stars and gas and then continued on its way. The black holes weren't close enough to basically spiral into each other. One just zoomed past
grazed.
The other. Yeah, they grazed.
Okay.
And of course, the bigger galaxy
mass,
the bigger galaxy wins and sucks.
Got it.
Sucks off the stars and gas.
Okay. You ready for share again? Yes,
yeah.
No?
So
okay.
Yeah. So just what's the difference between the different ellipses? And it's just shape. Elliptical galaxies contain older stars with no gas or dust. E0 galaxies tend to be smaller and less massive than E7 galaxies.
Okay.
So it looks like the more massive they are, the more likely they are to have a
not just shape, it's
right. Although it can look spherical if you see it end on. Yeah.
Okay.
So are new stars formed? Yes, but not nearly the frequency.
Cool.
Do they contain dark matter? Yes.
Apparently 90%.
Yes. So this is a fairly well thought out article, and I'm going to have to look for more by Telescope Nerd just to see.
Yeah, that sounds terrific.
Yeah.
You sharing the link?
I'll do that right now.
Okay, great.
I've got a bunch of links to share, but I'll share this one right now.
All right.
And
Yeah, that sounds like a good one for any of us.
Yep. So there's Telescope Nerd.
Okay, cool.
And, I'm going to...
It's probably clickable. It looks like it's short enough to stay together, so...
Yeah, and I'm going to share the space.com one, too, just because that's a good article, too.
Great.
And then we get into the wiki.
Okay, you ready?
Yeah, sure. And it says mostly the same thing, but it has pretty pictures.
Nice.
So I figured we'd go with the pretty pictures.
Absolutely.
And
we are very blessed in that department.
Yep. And you might recognize this one as the picture that we used for this episode.
They're just like a big fuzzy ball.
Right. Yeah.
Wild.
Yeah. And some of them do have some dust in them, and they appear even fuzzier.
Okay.
But, here's an elliptical galaxy after something happened. My guess would be that a lot of stuff fell into the black hole and it blew it out of its
Yeah, it looks
axes.
like just a bunch of ejected material.
Yep. And here's an elliptical, but with a bunch of spirals. This is a sort of thing that I saw in Galaxy Zoo. And here is another elliptical. You see an awful lot of dust here.
Yep.
Not inside the galaxy. It's between us and the galaxy. So my guess would be it got blown out.
Okay, so it just drifted between.
Yeah, and they also have a bunch of other links or other rabbit holes to drop down. And so I'll give you that one.
Great.
All of the other wiki links come from that one, so I won't bother sharing those.
Okay, you can find a whole bunch.
You can rabbit hole yourself. Yeah.
Particular article. Very good.
Yeah.
All right.
Yeah, and so this is where I got that image.
Yes.
And again, more different images. This one's kind of interesting. This is the near infrared of the different galaxies.
This reminds me of the Hertzsprung-Russell diagram, which actually is a way to classify the various stars.
Right. And this is basically the morphological classification of galaxies.
Okay.
And, this is the E number, and this is the equation for the E number. And so, yes, it's math. You can look at this one for the math.
All right.
Spiral galaxies, lenticular galaxies, and again, more pretty picture. That's a spiral. This looks like
a wild looking thing.
Yeah. Well, this is false color.
Okay.
Young stars are blue, so something happened in the recent history of this one, because that has a lot of young stars.
Yeah. Well, I mean, seems like in this collision there would be formations of new stars.
Yeah. Now here's something interesting, and this would be a reason to look for this. I might actually share this one just for this. Classifications of galaxies. Like the most stars are A through F stars. FG would be F and G stars. GK would be mean, and K.
Okay, so that is the spectral type. It says at the top. Okay.
Yeah. And then this is barred spiral, rotational symmetry without pronounced spiral or elliptical structure. Okay. Elliptical with dust absorption. So you're seeing dust. It's either inside or between us and the irregular, low surface brightness. So these are how they talk about the shape, and then the inclination. How on edge to us is it?
He's doing that.
Yeah. And so example, Andromeda Galaxy is KS5.
Okay, go back up. K
is prominently K stars. S is spiral, and 5 would be
closing in on edge on.
Yeah, closing in on edge on. So that's how they classify.
So there's 7 degrees of whether it's face on or edge on.
Right. Yeah.
Interesting. What do they call those? this type of classification? Let's scroll up a bit, see if we got a name for
Yeah, it is. Yerkes
or okay.
or Morgan scheme. Yeah, so
MK scheme system.
yeah.
Okay.
So
I don't think I've heard of that before.
yeah.
Oh.
This was new to me.
Cliff says that is very good information.
Oh, thanks. And I think
it is indeed.
Yeah. And then let me share that link just because the stuff on the bottom of that is.
And you know, I was asking you a question, but I forgot to share the screen. So why don't you go back to the top of that where it's called, what it's called, and maybe review it. Just nope. Just
the
okay.
Yerkes.
Yep. There it is. Yerkes or Morgan scheme MK system.
Yep.
For the classification of stars through their spectra.
Yep.
And there's the spectra type. Go ahead and next chart. Galactic shape and inclination. So those three things contribute to that K, like in this case, KS5.
Right.
For Andromeda.
And it gives
I had not heard that before.
Very easy way to classify any galaxy that you see.
Nice.
And now these are the dwarf ellipticals.
So what does that mean, dwarf elliptical?
Really small.
Okay.
Sorry.
Well, they don't give numbers or anything.
Right.
Okay.
But if you look at this, it looks just like a star cluster.
Yeah, basically looks like a globular cluster.
Yeah, but it's a small elliptical galaxy.
Interesting. Okay.
And so yeah. And then the type CD, which is a large elliptical.
Okay.
And
does that still fit in that?
Yeah.
Was it MK system?
Oh, actually, the D means that it's not quite elliptical shaped. And these are similar to lenticular or elliptical galaxies, but many times larger. So it's what happens if an elliptical galaxy gets really super big.
Okay.
I might, if there's enough on this, I might cover this more as a type of galaxy, but I think this is just a subcategory. But and here's where that's a spiral, of course.
Beautiful.
It's that one's elliptical. This is NASA.
No, the other one has I remember the name, but I don't remember. I mean, I've heard the name, I don't remember it. What does it say there?
M101 Pinwheel.
Pinwheel Galaxy.
Yeah. And this is...
And that's certainly what it looks like.
Yeah. This is an elliptical, lenticular, irregular galaxies.
Okay. Almost seems like it's, again, this smashing through.
Well, my thought is that irregular galaxies are going to end up as ellipticals eventually.
Okay.
But they're just not there yet. I don't know.
Interesting.
I mean, I don't know whether we're finding them close, because I haven't studied these, and I might next. But if we're finding them far, then then they haven't been around very long at the time that we spotted them.
There's a lot of blue in that one too.
Yeah, if we're finding them nearby, then then they've happened. I don't know. I think that these are fairly young, and like you said, there's a lot of blue in it. And I think that there's still a lot of stuff happening.
Yeah, in general, for those who aren't aware, if you have more blue colored stars, they're younger, and more red color stars are older.
Right, yeah.
And basically it's pretty much heat. The closer to white, which is like white and blue and yellow,
the hotter it is.
The hotter it is, yeah.
And I'm going to, just because that has a lot of galaxy types, and more than just the 3 or 4 that most people think about.
Great. Love it.
Giving that. And here we have just basically pretty pictures.
Nice.
So I'm going to show pretty pictures.
All right.
There's a different pretty picture. And here's a whole bunch of NASA pretty pictures.
We sure like our pretty pictures.
Yeah.
That's clear.
And
Oh, look at
here's
that.
one with a band of dust between us and it.
It'd be easy to mistake that for.
Well, and this might be blown off stuff, but see all of this blue around the edges of the dust?
Stars probably
New stars
formed just recently.
Yeah, so probably in that dust cloud too.
Yep. Like one of those stellar nurseries they talk about.
Right, but it doesn't look like it's in the galaxy, so it looks like it got blown off the galaxy.
Okay.
And
Interesting.
another this is ESA website.
European Space Agency?
Yep.
Oh yeah, I see those.
They don't say a lot about it, so I didn't really cover this, but pretty picture, so I wanted to show it. And of course, this is the APOD list of elliptical
picture of the day, yes.
Of elliptical galaxies that NASA basically put together. If you look through the NASA website, they have a link to this, and it shows the 3 pictures on here of elliptical galaxies.
Oh, 3. Okay. Not the 3 types of.
No, it's just.
Okay.
It was on their page. It was on NASA's page about elliptical galaxies.
Because if you recall at the very beginning, Jeff was saying there's basically 3 types.
Right, and there's actually more, but.
Okay. Well, is Hubble, it more or is it variations in those 3?
I think variations.
Categories. Okay.
But,
all right.
But Hubble originally spoke of 3 types. No, 4 types, because one's irregular. Okay. And they called spirals and barred spirals different, which I don't know that they're actually, they might have different processes. So we'll call them. And here's another one of just irregular galaxies.
That is irregular.
Yeah. And it looks very much like two galaxies are doing a tango.
Kind of one's went through the other one, huh?
Yeah. The small Magellanic Cloud is a very good example of an irregular galaxy.
Oh, okay.
Because it blew through our galaxy a couple of times, at least. And it just made, so it's kind of like stuff just got pulled all over the place. So. Yeah,
because at that point it was a very chaotic system. Yeah. It's not this nice, organized spiral. Mm-hmm. Eventually, it's just.
Yeah.
They run into each other. Oh, there's a good. Oh, that's really good.
Yeah.
Spiral, barred spiral.
Yep. Elliptical, irregular.
Regular.
So, I'll throw this one in there. It doesn't contain. It just has pretty pictures. Doesn't really contain much more information than we've seen it elsewhere, but hey, pretty pictures.
So we've done 2 out of the 3 kinds. I guess we'll eventually get to irregular and.
Well, there's
maybe some more.
We did spiral and barred spiral together.
Yeah, basically it's that same type, that same category.
There's irregular, and if there's enough there other than just it's the midpoint, it's soon after collision before things have. But if there's anything more than that there, I'll probably do one on it. And the other subtypes that they found, if there's enough on them, I'll do them.
Okay, great. Cool. Is that what you have for this?
Yeah.
Okay.
That's what I've got.
Because I have a little comment here. I'm requesting quotes for a press release. We actually hit 5 years tomorrow. Tomorrow is our 5th year anniversary of doing this show. Can you believe it? But yeah, I want to get something going and send it out. Just even 1 or 2 sentences encouraging others to come and see the show would be great. Here's that link or email again. It's pam@everydayspacer.com.
Yep. And
that works for all kinds of stuff.
So yes, 52 episodes a year.
More than Star Trek.
Yeah.
More than the original Star Trek. Let's put it that way. It's like, ooh.
Yeah, more than 250 episodes.
Yeah, some shows don't even get to 100, like, regular network shows.
Right, yeah.
Yeah, so, well, thank you for that. I really appreciate any comments you may have, especially if they encourage other people to come and watch the show. And just so you know, Everyday Spacer is sponsored by CME Computer and IT Solutions. Thank you so much.
Mm-hmm.
Let me start over. Some stellar events this week.
Easier for you to say.
No, we're talking September 19th through September 26th, and Globe at Night, just so you know, continues through September 23rd. We're looking for 2 different constellations, and they're separated by northern hemisphere and southern hemisphere. In the northern hemisphere is Cygnus, this is the one you're gonna look for. In the southern hemisphere, it's Grus. And that's basically a good way to report back to them. It's a citizen science project to report back to them what things look like in your particular spot on the Earth. And anybody in the world can do this. September 20th is the moon is at descending node, and Saturn is at opposition. It rises at sunset. And I was trying to figure out how that works, because I think it's in the west. Okay.
Well,
I don't know.
Might not be.
Well, I was looking at the Heavens Above app on my phone, and it says, "Oh, there's Saturn." I thought it was in the west. Anyway, so opposition, we know that for sure. Rising and sunset, I'm not so sure. September 21st is the new moon, and is a partial solar eclipse. It's visible from the South Pacific, New Zealand, and parts of Antarctica. Also, the moon is on the equator. September 22nd is the equinox, and they're counting it as 12:20 p.m. CST, which I thought was Central Standard Time, but you think it's
I don't know.
Zulu time.
But it's at 12:20 September 22nd. Right.
And Mercury and the moon are in conjunction. September 23rd, Neptune is at opposition. And opposition is when, the Earth passes in between the sun and the object, in this case, Neptune. And it's pretty much the best time to get photos of that particular object. Now, things like Neptune are going to be pretty far away. You want some really good optical equipment for that. The other one, what was
Saturn?
Saturn much easier. Much easier to get pictures of with regular equipment you might actually have on hand. Also that night, the 23rd, Spica is 1.1 degrees north of the moon. September 21st, Mars and the moon are in conjunction. Mars is 3.9 degrees north of the moon. And September 26th is the moon is at apogee. That's also our Friday night show. We're going to explore another request from the audience a few weeks ago. We're so excited that you have all these great ideas for us to delve into and bring back to you in the form of information, and see what we find. We never know. Of course, we learn stuff all the time. Find us Fridays at 9 p.m. Pacific time on the Everyday Spacer Facebook page and the Everyday Spacer YouTube channel. What inspires you the most for the coming week? And as we were saying, requests for any show topics. We would love to see the things that you're interested in. I mean, the more interested you are, the better we can help you. What maybe something you find challenging. Either way, we'd love to see if we can go there for you. All right, well, you're up.
Yep. So if you or someone you know has done something interesting involving space exploration, science, or astronomy, we'd love to share our live. Join us again next Friday, September 26th, for Other Dimensions.
Can't wait. It's such a fascinating topic.
Yep.
And of course, I think we all know about first dimension. Is that the dot?
That's a point. Yeah.
That's just a single point.
Yeah, two-dimensional.
A line.
No. 1D is a line. 0D is a point.
Okay.
1D is a line.
We'll get it straight for you.
2D is a plane.
Okay. Right. Yeah.
And 3D is basically three-dimensional world like we live in. 4D is actually three-dimensional world with time movement.
Wow. Okay. That's. We got some comments. You got them?
Yeah. So Cliff says, Crux, the Southern Cross is right on top of us at the moment. When the weather has that rare moment of clouds, or without clouds?
Without clouds, I think he means.
Yeah.
Oh, what is that? 3i Atlas?
Would be a good show topic. Okay. If you have any more on that, let us know. Otherwise, we'll look it up.
Yeah.
And Janie says,
I don't think I've ever heard of that.
Happy anniversary, Everyday Spacers.
Yeah. Thank you, Janie. 5 years. That feels like a long time sometimes.
5 years, which means that we'll have wood.
Oh, boy. You people. All right. Anything else for you?
No, I think I've cost enough.
Yes, you have. We will continue to watch for your comments as well. Thanks so much for being here. It's always a better show when you are. We had Janie and Daniel came and Cliff.
Naomi.
And
Dawn.
And Hein Cherry was here.
Pine Cherry, yeah.
We're missing Scott. Where's Scott tonight?
Oh, and Cliff says interstellar comet. Oh, interstellar comet, yeah.
Oh, is that the Three-Eye Atlas?
Yeah. And Dawn says happy anniversary. Thanks, Dawn.
Thanks, Dawn.
And Naomi, yeah, says happy 5th anniversary. Have a great week. Oh, you too, Naomi, and everyone. I hope you guys have a really good week. And
5 more years. Well, with any luck, it'll go, for a long time, because it doesn't have to be just us. Anybody out there who's interested in space exploration can be an everyday spacer person and show up on the show. I mean, I've been to Dawn's place, and Cliff was here, and he and Jeff took over one night, and it doesn't always have to be us. It's all of ours. It belongs to all of us.
Yep.
Yeah. So, all right, folks, have a really great week.
Yep. Maybe eventually we'll train up some mini-me's to do the show.
We need minions. Wouldn't that be exciting? And beyond, yes, and beyond. Thank you so much, folks. Have a great week. We'll see Janie tomorrow, and we will see you, the rest of you, next week.
Yep.
Good night.
Good night.